All right, I do want to welcome you to this worksheet. This is called Naming and Writing Formulas for Mixed Compounds. Folks, this is going to incorporate everything we've talked about up to this point, including covalently bonded compounds, simple ionic compounds, compounds involving transition metals, and compounds involving polyatomic ions. So we're going to kind of put it all together here. On this worksheet, we're going to need a periodic table and the polyatomic ion chart. So if you don't have those, go ahead and get those, and we'll get started. All right, I'm going to be moving fairly quickly through the first 20 because they're pretty simple. We're simply going to take the formula and convert it into a name, so not too terribly difficult, and we'll slow down a little bit on the last 20. So let's look at number one. We've got silver, which remember is a transition metal that has it has one oxidation number, it's +1, and nitrate is a polyatomic ion, -1. So -1 and +1 have to cancel each other out, and they do. So we call this simply silver nitrate for number one. On number two, we have iron, which has multiple oxidation numbers. Oxygen is -2, and there are 3 of them. These charges have to balance positive and negative. So -2 times 3, -6. So what times 2 is +6? Well, +3. So that would make it iron Roman numeral 3 oxide because the charge on the iron is +3. So iron Roman numeral 3 oxide for number 2. Let's look at the third one. For the third one, we have calcium and we have nitrate, CaNO3 in parentheses 2. So calcium has a charge of +2, nitrate has a charge of -1. That's why there's a 2 right there. But when we name it, we simply call it calcium nitrate for number 3. The next one is SO3. Got to be careful here because this looks suspiciously like a polyatomic ion, SO3, but it doesn't have a charge, and because of that, it's not an ion at all. It's a covalently bonded compound. So we use the monodi system. We don't say monosulfur trioxide, but simply sulfur trioxide. Remember, if the first one is only one, we don't call it mono. We simply call it, in this case, sulfur trioxide for number 4. Number 5, this is simple. This is as simple as it gets, as a matter of fact. We have potassium and chlorine. We simply call it potassium chloride. Potassium from the first column, chlorine from the 17th column, potassium chloride for number 5. Let's go on to number 6 now. In number 6, we've got an element that has more than one oxidation state possible. Tin has more than one oxidation number possible, so we have to name it in the compound. In this case, fluorine is -1, but we have 4 of them. -1 times 4 is -4. Tin must be +4 to balance that, so we have tin, Roman numeral 4, fluoride, just like that for number 6. Occasionally, we have polyatomic ions for both the cation and the anion. That's what's happening here. We've got ammonium sulfate for number 7. Number 8, remember that zinc it's a transition metal, but has only one possible charge, or oxidation number, it's +2. Oxygen -2. Those two have to balance. So we don't name, because it only has one possible oxidation state, we don't name the charge on the zinc. We simply call it zinc oxide. And it would be incorrect, by the way, to have called it zinc Roman numeral 2 oxide. So that's number 8. Let's look at number 9 now. On number 9, we have another polyatomic ion. This time it's sulfate. We have barium sulfate. Pretty straightforward for number 9. Next one, number 10, we've got sodium, another polyatomic ion. PO4 is phosphate. So sodium phosphate. It's an ionic compound containing a polyatomic ion. So sodium phosphate, just like that. The next one, lithium. Here's another polyatomic ion. We can call it bicarbonate or we can call it hydrogen carbonate. Either one is acceptable. So lithium, I'll call it lithium bicarbonate this time on number 11. So lithium bicarbonate for number 11. And number 12, another polyatomic ion, KMnO4 permanganate. So that would be called potassium permanganate. Potassium permanganate for number 12. Number 13, another polyatomic ion, calcium carbonate. We have CaCO3. Calcium carbonate for number 13, fairly straightforward. Calcium has a charge of +2. Carbonate has a charge of -2. They have to balance, and they do. We call that calcium carbonate, just like that. Number 14. Let's look at number 14 and 15 together. Notice that copper is involved in both of these. Copper can have a charge of +1 or +2. In the first one, we have chlorine there's only one of them. So -1 times 1 is -1. That means that this copper has to have a charge of +1 to balance. So we call this copper 1 chloride, just like that. Copper 1 chloride. The next one, however, has 2 chlorines. So -1 times 2 would be -2. So this copper must balance the load. It must be +2. So we say copper Roman numeral 2 chloride for number 15. Number 16, we're back to molecular compounds, right? We're back to compounds that are both, or elements that are both on the right side of that zigzag line. We use the mono-di-tri system. We would call this diphosphorus pentoxide. Notice if there are two vowels together, we drop the second vowel. So it wouldn't, or the first vowel actually, we call it pentoxide, not pentaoxide. Diphosphorus pentoxide for that one. Let's look at number 17. Another covalently bonded compound, both carbon and chlorine on the right side of the zigzag line. We go back to the mono-di-tri system. 4 is tetra, so we say carbon tetrachloride for number 17. Carbon tetrachloride. Number 18, we're back to copper. Remember, it could be +1 or +2, but sulfur is -2. That would make copper +2, just like that. Copper, Roman numeral 2, sulfide for number 18, just like that. Number 19, hydroxide is OH, so we call this calcium hydroxide. Calcium is in the second column, so we don't have to worry about charges there. And the last one, magnesium sulfate. Again, sulfate is a polyatomic ion. Magnesium in the second column. Again, no need to worry about Roman numerals this time. We simply need to concern ourselves with the fact that magnesium is, or Mg is magnesium. So we have magnesium sulfate just like that. All right, let's move to now to compounds where we're given the name and we need to figure out the formula. Hexa indicates that this is a covalently bonded compound. So sulfur hexafluoride would be SF6. Hexa is 6. So sulfur hexafluoride, SF6. Let's look now at iron 2-phosphate. Iron 2-phosphate would be Fe3PO42. How does that happen? Well, Fe, they're telling me in the name, has a charge of +2. I'm going to switch this charge and this charge. In other words, I'm going to bring the 2 here and the 3 here. Notice I said 2 and -3. So that goes, the 3 goes here, the 2 goes here. We're only interested in the absolute value. We're not interested in the charges now when we bring them down to subscripts. So again, Fe3, 3 from up here, PO42, 2 from up here. Notice that I have to have parentheses around the PO4 because I don't want it to read PO42. I can't distribute the 2 like I would in math. I can't say P2O8. It has to be exactly as written, Fe3PO42, just like that. Sodium chloride, pretty straightforward. We have +1 and -1. They're going to cancel each other out. There's no need for me to write either the plus or the -1, or either one right there. They're going to cancel. Don't put ones as subscripts, so it would just be NaCl for that one. Let's look at nickel 2 nitrite. Nickel has a charge of +2. It says so in the name. So I'll do the crisscross just like this. Nitrite, I'm sorry, is -NO2 -1. So when I do the switch, the 1 goes here. Don't write it. The 2 goes here. Make sure you put parentheses. You have to have them. You can't write NiN2O4. You cannot distribute that 2. It becomes NiNO2 in parentheses 2, just like that. Iron 2 oxide. Iron is going to have a charge of +2. It says so in the name. Oxygen is always -2. So when I do the switch, just like that, they're going to cancel each other out. So don't put a 2 here or 2 here or even a 1 here and a 1 here. It's just FeO for iron 2 oxide, just like that. Let's go on to number 26. Number 26 is silicon dioxide. Remember, if you see a mono or a di or tri, you're back to covalently bonded compounds. That's what we've got here. It's not monosilicon dioxide, it's just silicon dioxide. So I just write SiO2 for number 26, just like that. Number 27, lithium iodide. Lithium is +1, iodine -1. Let's do the switch. We just move this +1 down here as a 1, this -1 here as a 1. Neither one of them shows up in the formula. We just call it LiI, just like that, and that is number 27. Let's look at number 28, chromium 3 bromide. Chromium has a charge of +3. It says so in the name. Bromine is -1. What I'm going to do is I'm going to do a switch just like that. So chromium has a 1 here, but don't write it. Bromine has a 3 here. I do write it. No need for parentheses here. That's the correct answer, CrBr3, just like that. We've got sodium bicarbonate. Sodium has a charge of +1. Bicarbonate has a charge, or hydrogen carbonate, I can say it either way, has a charge of -1. When I do the switch, 1 and 1 simply go away. I could have put parentheses around the bicarbonate, but it's not necessary because there's no subscript after the bicarbonate. So I'm going to write it simply as NaHCO3, just like that. The next is lead 2 chloride. Lead has a charge of +2. It says so in the name. So I'm going to say lead +2, chloride -1. When I do the switch, look what happens. 2 goes right here, 1 goes right here. Don't write it. That's number 30. Let's go to 31. We've got strontium nitrate. Strontium nitrate is Sr. It's going to have a charge of +2 because it's in the second column. Nitrate is a polyatomic ion. It's going to have a charge of -1. Let's do the switch. There it is, right there. Now, strontium has a 1 right here, but I don't write it. Don't write 1s as subscripts. So we have strontium nitrate is going to have a 2 outside it. Don't forget to put the parentheses. We don't want NO32. That's what it'll look like if we don't put the parentheses. So it's SrNO3 in parentheses 2, just like that. Next is potassium hydroxide. Here we've got a polyatomic ion. No big deal. Potassium has a charge of +1, hydroxide -1. We're going to do the switch just like that. There it is. Don't write the +1. Don't write either one. Don't write a 1 here or a 1 here. No need for it. It's just 1, 1, but don't write them. So that's potassium hydroxide. That's number 32. Let's look at the next one. We've got a polyatomic ion in ammonium. Ammonium is NH4, chloride is Cl. We've got ammonium chloride, NH4Cl, just like that. That's number 33. Number 34, we've got tin 2 fluoride. Tin has a charge of +2. Fluorine always has a charge of -1. We'll do the switch just like this. We've got tin, don't put the 1. Fluoride gets a 2. That +2 becomes a 2 down here. So we've got tin 2 fluoride, SNF2. Next one, diarsenate trioxide. That di and tri means we're dealing with a covalently bonded compound, so we have As2O3, di 2 tri 3, As2O3 for number 35. Let's look at 36 now. Number 36 is potassium acetate. Potassium has a charge of +1, acetate a charge of -1. They're just going to cancel each other out. It's that simple. They're just going to cancel one another. So we have potassium and acetate, or potassium acetate, are just that right there. Could have written parentheses around the acetate if I wanted to. Wouldn't have hurt anything, but it's not necessary, so I didn't put it. That's number 36. Number 37, we have copper 2 sulfate. Copper has a charge of +2. Sulfate has a charge of -2. When I do the switch, they just go away. So +2, -2 disappear in the final answer. I could have put in parentheses around the SO4. Not necessary. I elected not to do that. If you put it, that's fine. It doesn't hurt a thing. So that's number 37. Number 38, dinitrogen tetroxide. Di, tetra, we're dealing with, obviously, a covalently bonded compound. Remember when you see mono or di or tri or tetra or penta or hexa and so forth, you're dealing with a covalently bonded compound. So there's no switch. We just write what we see. Di means 2, nitrogen, dinitrogen, 2 nitrogens. Tetra, 4 oxygens. N2O4. And by the way, you cannot reduce these. If it says dinitrogen tetroxide, it's N2O4, and it has to be written exactly like that. N2O4 is not the same thing as NO2. So don't reduce, write exactly what you see. Next, number 39, aluminum oxide. Aluminum is in that third column, or 13th column. So we have aluminum +3, oxygen -2. We do the switch, and we get this. Al2O3. This whole thing now is called a formula unit. It is balanced, right? It is balanced. So that's that. And finally, mercury 2 sulfide. Mercury has multiple oxidation numbers. This time, though, the charge is +2. I know from the name it's +2. Sulfite is SO3 -2. When I do the switch, just like that, right? When I do the switch, just like that, we get HgSO3. That's mercury 2 sulfide. Mercury 2 sulfide. Folks, I hope that this is cleared up. Any questions that you might have on nomenclature, remember that on an exam or a quiz, you're going to see all different variations. So make sure that you can do this. Folks, I'll see you on the next one. Have a good day. Bye-bye.